Hi everyone. Good afternoon as well. Uh, So the points standing from the first two meetings are Stephanie leading with 6 points, 60 points, sorry. Sanjay on 5, 50, and Joffin on 30, and myself on 10. So Sanjay, Joffin, and you others can pass out Stephanie today because we have 12 questions, some of which have 2 points and our 2 points and 3 points. So anyone knows how to make wine or wine is made?
Alright, so hi guys, welcome back to another meeting. Today we will be doing winemaking, as Mikhail would have insinuated, and you would have seen on our poster or flyer for today. So the fruits that we have are pineapple, banana, and we have a few apples. So we're going to integrate that into what we're doing. I want to show you guys how far we are. We are currently prepping the fruits. So let me just turn the camera so you guys can see. So these are the bananas. So we already started cooking some of them. I'm gonna dice them up. Those are the pineapples. Tiffany's here, of course. So we have a few apples. Yes. And fruit's expensive, guys. God know this big dog in my pocket. God know. But we have bananas and pine. Think we have more banana than pine? What? Yeah, kinda. And then we have a few apples. So we're gonna add that to the mix. We're aiming to have about three types of wine. So we probably do one pineapple, one banana, and then we try a mixed wine, a mixed fruit wine. So we are currently prepping. So I'm doing the peels here for the banana, and then we're going to dice up everything on the cutting board, and then we go to the blender. So while we're doing that, we're just going to go through a bit of the theory, of course, while we're prepping, so that you guys can be familiar with what we're doing. All right. So wine making. The first wine that was, well, recorded to be made was done in Georgia in the USA in 6000 BC. And there's also evidence of wine being made in China, Iran, Greece, Armenia, other countries far back in history. So many of the microbes that we have in our environment, they are capable of converting or obtaining energy by consuming sugar. So if you guys ever had an interest in microbiology, to say we know that microbes can actually metabolize sugar and they produce ethanol as a byproduct. So, of course, we know the most common one is the yeast that we use to like bake or make our wines and rum and other alcohol. So, ethanol is known to kill most microbes. So even after they produce the ethanol themselves, um, when the ethanol, even at low concentration, is produced, then it can kill them. But yeast can actually survive up to 20% ethanol, which we don't need 20%, to be honest. That is way too much. So before it is overcome, it can survive 20% ethanol. So that's a lot of ethanol. So that makes it very useful to be used for winemaking. So this is just a diagram showing the stepwise processes of making wine. So we know wine making, we're accustomed to using grapes to make wine. That's the most common fruit that is used. But we also know that you can use other fruits because the principle is the same, even with other fruits. So for the winemaking, we're seeing where we obtain our grapes and we crush them or press them, ferment them, and then we clarify, age, well, clarify, bottle, and age. Some wines are aged and some are not. So this is just a general diagram of the processes that happen in winemaking. So there are 5 main steps in winemaking. So the first one is harvesting. This is where you are going to get your fruits, and then you crush them, after which you're going to ferment them, which is really the main part of the process. And in some cases, it's the longest part of the process. In other cases, aging is the longest process. That's if you age your wine. So after fermentation, we have clarification, and then we have aging and bottling. So harvesting, as I said, is where you're getting your fresh, fully ripened fruit, and that's the preferred raw material. Because remember that we need the sugar that's in the fruit, so you want them to get ripe. In some instances, you may have sugar deficiency, such as when you have a lack of sufficient heat to produce ripening. So in some colder climates, they don't have a lot of heat. So this can be corrected by actually adding sugar through a process known as chaptalization. You're adding sugar to your fermenting mixture, or you add some juice concentrate, which has the sugar. The proper timing of your harvest is of great importance because, as I said, you want the fruits to be fully ripe but fresh. You don't want them to be starting to rot or anything like that. So, premature harvesting usually results in thin, low alcohol wines, and we can, of course, understand why they would be low alcohol content because if the fruit is premature, it doesn't have as much sugar, and so not as much alcohol is going to be made. Very late harvesting will, however, give you a high yield of alcohol, but low acidity in the wine. The harvesting can be done by hand or by machines, but most winemakers prefer doing it by hand because machines can negatively impact the grapes as well as the vineyard. So they would prefer picking the fruits by hand. And once you obtain those fruits, you take them to the winery where you sort them. So all of those that are underripe, or if they're rotten or they're starting to rot, then you would remove those. So once the fruits are sorted, and in some instances you de-stem it if there's a stem, if there are peels, you remove the peels like in the banana that we did, or the pineapple we use, you peel it, or if you have seeds, you remove the seeds. You're gonna remove all of that and you're gonna crush them. In our case, we're going to blend it because that's just an easier process. So you're going to blend it. For grapes, we know that in the past, this crushing has been done with your feet, something that you call foot treading. But now we have, it's modern times, so we have machines to do that kind of work for us. So the crushing process is done mechanically now. And what you produce after crushing or pressing is what you call the must, or well, in the case of grapes, you call it must. So our next big step is fermentation, and that's really the major step of the process because that's where you're going to get the alcohol and your sugar is going to be converted from fructose or sucrose or glucose, whatever form it is in the fruit, is going to be converted to ethanol eventually. So in most instances, fermentation happens naturally, especially with grapes, 6 to 12 hours within harvesting them. They may have wild yeast on them, so the fermentation can start at that point. But wild yeast is unpredictable for a final outcome, and you want to have an idea of what you want for your final outcome as well as to ensure consistency. Like for manufacturers, you want every bottle of wine to taste the same or have the same alcohol content, etc. So for consistency purposes, they add cultured yeast, which is what we're going to use today to transform the sugar into alcohol. The fermentation process is carried out until all the sugar is turned into alcohol in the case of making dry wine. If you're making some sweet wine, then the process is usually stopped somewhere in between to prevent all of the sugar from converting. All right, so in the process of fermentation, there are certain requirements we have to ensure that are in place for the process to occur efficiently and effectively. And one of them is the suppression of growth of undesirable microorganisms. So we had said before that microorganisms are able to convert sugar into ethanol, which means that if you allow undesirable microorganisms to grow in your suspension or what you are fermenting, then that's going to affect the yield of alcohol that you obtain. So that means yeast is not going to be the only thing that is operating or carrying out processes in fermentation. That means you're going to have other microorganisms operating. They may even convert the alcohol to other byproducts, which you don't want to happen. So you want to ensure that you don't have growth of any other microorganisms in your suspension. You just want the yeast alone to be there. You have to ensure that you have the adequate number of desirable yeast, and that depends on the type of wine that you're making. So let's say you're making some sweet wine, You don't necessarily want to add a lot of yeast because you don't want all of the sugar to be used up. If you are making some dry wine, you may add some excess yeast just to ensure that all of the sugar is used up in the process. The next thing is proper nutrition for the yeast growth. So you want to ensure that the yeast has enough fruit or sugar available for its growth or for it to carry out the process of converting sugar to ethanol. So you don't want to add too much yeast and too little fruit or sugar. You just want to add enough so that the yeast has enough to be used up. The next thing, and one of the most important things, is temperature control. Because we know that this process, well, we should know that this process being carried out by the yeast involves enzymes, and we know that enzymes operate at a particular temperature. The optimum temperature for this process is 22 to 25 degrees Celsius or 72 to 77 degrees Fahrenheit. So you want to maintain it within that narrow range so that you don't have anything going wrong in the process. You also want to prevent oxidation. So it's important that you use an airtight container for the process so that you don't have air going into the suspension or anything. Because, we should know what happens when air comes in contact with your ethanol, what it gets converted into. So ethanol can be converted into ethanoic acid or acetic acid, the same thing as vinegar, when it comes in contact with air. So basically, all your wine or alcohol will just turn to vinegar. And then you want proper management of the cap because you're producing carbon dioxide in the process. You want to ensure that the caps that you add to your vessels, that they allow the release of air, because if you have buildup of pressure, eventually the thing is going to burst or the top is going to fly off, and that will just create a mess, and it's going to expose everything to oxygen. All right, so you have different types of fermentation. The main one, is primary or alcoholic fermentation. That's the main stage where you're just breaking down your sugar to release carbon dioxide and alcohol. And as I said, it can happen naturally with grapes if it has wild yeast on it. Then the process can happen naturally right after crushing. But of course, we induce the process by adding cultured yeast to it. So you also have malolactic fermentation, which is where malic acid is converted to lactic acid and carbon dioxide. This helps to reduce the acidity of the wine. So in this process, the wine is stored in an airlocked tank. You avoid contact with air because you don't want it to get oxidized. And then you're going to have where the proteins in the grapes or whatever other fruit that you use, those break down. And the yeast cells and the other fine particles just set to the bottom of the vessel. So you're going to end up with a vessel having clear wine in it. So that process, the malolactic fermentation, it takes a longer time, so a couple of months, 3 to 6 months. For lighter wines, you generally don't use malolactic fermentation, but for other wines, especially if you want a higher alcohol content, then you carry out malolactic fermentation. All right, so this is just a picture of the process basically how it works. So we'll be using some 6-liter water bottles or jugs today to carry out the process. Yeah, instead of those glass jars. So we will be attaching the tubing and everything to the top of the water bottles and then kind of leave it for about a week, checking on it periodically. All right, so before we go on to the next step, which is clarification, we're just going to update you guys on how far we are, on our progress, I should say, in the lab. So we're still prepping the floats. So we're pretty much ready to blend. No, we're almost ready to blend everything. So I'm going to update you guys on that before we go on to the next step of the process. All right, guys, so we are almost finished with the banana, just a few bananas to go. And we are here with the pineapples. So we are going to go ahead and I'm going to start adding the pineapples to the blender to blend it up. What did I do with the water? No need to add water. Alright guys, so we're currently at the blending stage. So banana finished up and the pine. So we're going to blend. So what we're doing is to blend the fruits with a little bit of water and adding sucrose to it. So we add some sugar to it. So we do that instead of when we blend and add the sugar to this and have to mix it. We're just going to blend the sugar into the water and the fruit, and then we add it to the bottle. So that's the stage we're at right now. Let's see if I can catch you guys so you can see. Yeah. So there it is. So even though the fruit itself already has sugar in it, we're adding extra sugar to it so that the yeast can have that to use to convert to ethanol. I'll push it down. I feel like it want more water. No. Yeah. Really, I'm truly tempted to eat them something, you know. God no. Let me eat to a banana them. I'm a little hungry. And I spent so much money on them. I remember eating breakfast. I was like, you know what, let me put one of these. Just pull it down. But you know what's so weird? So we're trying to move a little faster. So we have 2 blender jars. So we're just going to blend alternatively. That's the expensive sugar. Yeah, that shit away. Mercy. Expensive, man. And that shit will like say. And I'm money. we're trying to do them alternative. So while she's doing that one, just blend some more. So again, we're adding the sugar directly to this mixture that we're blending because it's just a lot easier than to add it here. People who make wine for a living. You know, people that make homemade wine. I would never. This is too much work. Way too much work to make money. Hi, Roseanne. Door open. Door open. Take it to the door. Okay. You can come in if you want. Hi. Yeah. All right, guys. So we're on the last lap for the pineapple, and then we're going to start the banana. Why is my camera so blurry? Huh? Oh. Hey, the camera. So this is the final batch for the pineapple, and then we're going to do the banana blending. That is, all right. What that is, push it down here, so then turn it, push down, turn. Push down, turn. Sit there. stuff, just shake up. Come on, guys. You're not heavy, you know, just hold your hand. Okay, so all right, so we're going to move on to the banana soon. So I'm just going to rinse out these stuff at the sink. I'm just going to rinse this so we can use it to blend the banana. All right, so in the interim, in the meantime, we're going to look at the rest of the steps in the process of wine making, and then we'll bring y'all back to the banana. So let's look at the other processes. All right, so we stopped at the fermentation process, which we said is essentially where we are converting our sugar to ethanol, right? And in our case, and in a lot of cases, you can add additional sugar to it. So to ensure that the yeast has enough sugar to work. So while we want to ensure that we have enough yeast, we want to also ensure that there is proper, as we said, that is a requirement for the process. So we want all right, so the next step in the process, would be our the next step in the process would be our clarification process, which essentially is when we finish fermentation and everything, and we now want to get all of the wine aside from the yeast and whatever else we had added to the mixture. So even chemicals that are found in the fruits known as tannins, the proteins, the dead yeast, because remember yeast is actually an organism. So it's not just this thing that you add, a chemical that you add to it and it does what it does. It's actually an organism. So it dies after a time. And we want to ensure that when the process is finished, we can remove all of that yeast, all of that protein, all of the other stuff in there that is not wine and that we don't need. So the filtration or fining process is usually used for the filtration or fining process is usually used for clarification. So in filtration, that's pretty straightforward. You're just getting rid of the larger particles. With fining now, you usually use a fining agent such as bentonite clay, which is what you add to the mixture and it absorbs all these things that you want to get out of it. So absorb means these elements or particles or substances, they are going to stick to the clay and then you can get to just decant off the wine, get the wine by itself and everything else is just left in your bottle or in your fermentation vessel. So your filtration, you may also have filtration along with centrifugation and filtration, which is where you rotate the mixture at high speed. That's your centrifugation to get all the particles that are not liquid to settle out. And then you can easily just filtrate, decant and filtrate to get the wine by itself. So after you carry out your clarification process, that's where you're going to transfer your wine into a tank and prepare it for aging or bottling. Alright, so aging and bottling process really. And in every case, you are going to do some bottling, but you have to bottle because you have to bottle the wine that you have produced, but not in every case will you do aging. So not all wines are aged. In most cases, making some fruit wine, you don't age it, especially if you want it to be light, then you don't age it. So in your aging process, you usually add your wine to oak barrels or even steel tanks or bottles of your choice. And you're basically allowing it to sit and age. Aging increases alcohol content, and at times it reduces the acidity of the wine. So usually wines like red wines are usually aged. Then I don't know who like red wine, but that thing is delicious. I don't know. I guess that's an acquired rich taste that I, as a rich person, don't have. So yeah. So you're storing your wine in oak barrels, usually oak barrels, for aging. And then bottling is pretty straightforward. You're putting them in bottles. If you're a company, you're going to add your label to the bottle and whatever. You add in your wine corks and all of that. And yeah, that's pretty much the process. So update, we are now blending the banana, which is which is a lot easier to blend as we expected than the pine. So we have a lot more banana than pine. We're going to mix some of the banana with some apple to make a mixed fruit wine. And then we're going to have one banana and one pineapple. So that would be 3 in total. So let me just show you guys what's going on right now. Alright, so I'm dicing the apples now. And we're going to mix it all up with the banana. You like that? That tastes nice. Especially as the juice. My God. One time I'm make my smoothie. Alright, so after this experiment, we're going to, of course, add an at-home version for you guys, which you can more than do at home, actually. As people make wine at home all the time. So all you have to do is get some yeast, which you can get at the store or supermarket. Preferably wine yeast, but you get regular yeast is fine. So you get that with your fruit, whatever fruit you have at home. You can get creative if you want and experiment, go outside the box. So you just cut up your fruits, blend them, get them in a container, add your sugar to it, and the yeast is the final thing that you're going to add. So, yeah. So over the days, we're going to show you guys what the progress is. So we have to check on it periodically to see how far it reach and them thing there. Make sure it not explode. All those beautiful things before the process is finished. You set them up, are we? So the process will take about a week to do, because we're not going to age it or do any malolactic fermentation. So we're just doing regular fermentation and then we get the wine. We filter it and get the wine. Alright. So I'm going to rinse this container because we're on the last banana one. Add this thing, please. Here we go. So we're on the last banana. So we're going to rinse this cup so that we can start the banana apple or apple banana. Apple banana sound. A banana apple. Apple banana. Yeah, apple banana. That sound better. I'm going to rinse this and start with the apple banana blend. Why that look like porridge? Alright. We're going to take some picture of the apple banana. I'm saying I'm bored. So far, this is the pineapple and the banana, about the same volume of both. And then we're doing the apple banana now. You put sugar in it? Hmm? Yeah. Put some more in there. This one is a limited edition, guys. It's not a lot, it's not as much as the common ones. From time, it's fine. What are these? Once again.
Ear traps.
Alright, guys, so we're adding the air traps to the corks for the bottles. So for the time that we're going to leave it to ferment, the air is going to come up in here, right?
Yeah, the carbon dioxide will come up in here. In this section, we're going to put water, or we can put a dilute bleach solution, dilute sulfite solution. But it's mainly to keep out insects and stuff. But here, we have some air spaces where the carbon dioxide can actually escape and prevent the buildup of CO2 in the reaction vessel to prevent an explosion. So yeah, so let's do this.
Boom. That's it. Think we need more sugar? We need more sugar. Oh, so for all of them?
Yeah.
Oh, all right, so add more sugar.
Hot distill water. So you need more, well, you're gonna be just empty this in another one.
All right. Guys, we just added both the pineapple one. So we're gonna add water, banana, and but the same place for the banana. All right, guys. So now we have finished blending and everything as you would have seen. So what we're doing now, we added some water to all of the mixtures to get it about to up here. This one is less because we had less juice in it or less fruit. So we're adding some more sugar to all of them because we want to ensure that the yeast has enough sugar in them to make sufficient amount of wine. And since we just added a whole bunch of water. So we're going to wash up these. You know what you described it to me? Look what I needed to put in there. Oh God, you would have did it sugar.
Well, this is banana. This is a mixture.
The banana.
This is but
Oh, this is the mixture. Okay. Label it.
remember label.
Yeah, you know what I'm saying?
Alright, now.
Let's label them. It's good practice in chemistry to label. So let me label them so that we know what is what. Let me mark that in now. Oh yeah, out? Oh, that's what I'm saying. Out. So this is the banana. This one is the apple banana. And this one is the pineapple. Why don't you call it pineapple though? Let's call it pine. Right, so pineapple, apple, banana. All right, this again, down here. First again, down here. No,
Some more, shall we do this?
alrighty, so we use almost 2 kilograms of sugar. Mighty Jesus. Almost 2 kilograms. That's about $400. And then $1,500 worth of banana. How much pine? I didn't know. Price. Add me add up. 6 for the 5 pound of pine. 5 pound with skin. Oh. Alright, let's put these in the garbage. I don't want apple seed. You want apple seed? Boom. So time to wash up these. And then we're going to add the caps to the jugs. Yeah. Never mind. That come back close to them. While oh God. This was a day's work. So we're going to add the yeast before we add the caps, guys. Just leave these and come back to them to rinse and see. We're adding them water. Water you put in them?
Mixture. Ethanol.
Okay. Or we use ethanol with the yeast too.
It's not a, it's a dilute solution. No, you can remember that the yeast in there produce ethanol. It only kills them at a specific concentration. And this isn't in the fermentation. It's actually going to sit on the top of it. So anything, microbes that are trying to enter, ethanol solution.
Okay. All right.
Alright, so yeast, just need a little bit.
Come on, say. You know, when you send the picture, I think it's a big pack or something, God, no.
This can actually serve for 5 gallons.
Whoa. Oh, we can just add liquor to each. Whoa. So we shake them up now? Shake them up?
I mean, close it down. Sorry, turn it. Right.
Woo. Yeah, work. So I just getting in there. What? Go down in there. Oh. All right, guys. So we're at the end of the road. Yes, mighty Jesus, my foot them hurt me. Could not do this for a living. So we've added these, as you guys can see. So we're adding the caps to the vessels. We're ensuring that they're not leaking, that none of this ethanol spills into the mixture. So to end the meeting, of course, we have questions. I have about 12 questions that we're going to go through. I'm pretty sure you guys have learned a lot. So the theory that we went through as well as the practical aspect of what we just did. So it's question time. Let's see if we did pay attention, if we were learning. I feel tired. So. Question time, people. All right, so first question, where was the first wine made? Is it A, Greece, B, France, C, Georgia, D? No. Where was the first wine made? All right, so I'm seeing some answers. I'm seeing Greece, I'm seeing Georgia, I'm seeing Italy. Somebody else said Georgia. Correct answer is Georgia. C. So Stephanie would have gotten that, would be the first to get that correct. So question 2. Machine harvesting is preferred to hand harvesting. True or false? Ask me why I spell preferred like that. Machine harvesting is preferred to hand harvesting. Is that true or false? I see person say true. I see person saying false. Why Michaela change her answer? You have to, well, you can change your answer, you know. Just know that the final one is the one I'm going to use. All right. So machine harvesting is not preferred to hand harvesting because we said it has a negative impact on the it has a negative impact on the fruits as well as the vineyard. So it kind of got destroy the vineyard if you use a tractor to just go through everything. So hand harvesting is preferred. Although it goes slower, you have to pay more people to do it. But it is preferred to machine harvesting. So the person with the first correct answer was Stephanie. I don't understand what's really happening, but Stephanie has the correct answer again. So let's move to the third question. So that was one, those are two 1-point questions. This is a 2-point question. What is the manual crushing of grapes known as? That is an easy one. That's the easy one. What is the manual crushing of grapes known as? Stamping. Right? Jesus. I don't know where Miguel gets stamping from. Correct answer is foot treading. So the first person with that correct answer is Joffine. So Joffine gets 2 points. So on to our next question. Question number 4, I believe. How many major steps are involved in winemaking? And note I said major. How many major steps are involved in winemaking? A6, B5, C4, D7. How many major steps are involved in winemaking? All right, the first correct answer I'm seeing is from Ciandre, that's B. Ciandre gets 1 point. So yes, it is 5 steps. And who can name the 5 steps? You get an extra 2 points if you can name the 5 steps and name them in order. That's me giving away 2 points. If you can name the 5 steps and name them in order, and of course be the first person to do so, then you'll get those 2 points. Okay, I'm seeing an answer from Joaquin. Seeing answers from Ciandre. Ciandre, type quick, man. Okay. So both, yeah, everybody's answers are correct. So harvesting, then crushing, fermentation, then clarification, and then finally aging and bottling. So we can see that Ciandre got those all 5 correct and in the correct order. So he will get those 2 points. So let's move to the next question. What is the direct addition of sugar to increase wine sweetness called? What is the direct addition of sugar to increase wine sweetness called? I'm positive I mentioned this. Any takers? So I'm seeing an answer from Jophine. The direct addition of sugar to increase wine sweetness is called chaptalization. So Jophine gets that point. That's 1 more point for Jophine. Let's move to the next question. Next question says, what is the 4th step of the winemaking process? And if somebody get this wrong, oh boy. Is it malolactic fermentation, aging, clarification, or filtration? How could you possibly get this wrong? Okay, so I'm seeing a question from Jophine and Ciantre. You guys are both correct. It's both. It is clarification. That is the 4th major step of the winemaking process. But Jophine was first, so she gets that point. So our next question. What is the ideal temperature for fermentation? Is it A, 72 to 77 degrees Fahrenheit, 70 to 75? Is it 77 to 79 or 70 to 74? Is it A, B, C, or D? Which is the ideal temperature for fermentation? Okay, I'm seeing some answers coming in, but are they the correct answers though? Are those the correct answers? Anybody else has an answer or would like to change their answer? You have a different answer or you'd like to change your answer to another answer, but I will be using your final answer first. Okay, so I'm seeing some other answers. Okay. All right. So the correct answer is A. It is 72 to 77 degrees Fahrenheit. So Jophine gets that point because she was the first person to get that correct. So let's go to our next question. After crushing, what is the resulting suspension referred to as? After you crush, and in this case we're talking about grapes. After you crush, what is the resulting suspension referred to as, or what is it called? All right, so I'm seeing some answers coming in. So everybody have the same answer, and it is indeed correct. But as always, Joffine is just quick on the keyboard. So Joffine gets that. Oh, those are 2 points. My bad. Those 2 points. That was too easy for 2 points. How come I put 2 points? So we're at question 8 out of 12. So we have 4 to go. All of the following are requirements of fermentation except temperature control, nutrition for yeast, oxidation, adequate yeast numbers. All of them are requirements except which one? A, B, C, or D? Okay, I'm seeing some answers. You sure that's the correct answer? And it's not something else? Are you sure that's the correct answer? And not something else? You're free to change your answers if you would. I mean, you don't have to change it if you stand by that answer, but are you sure those are the answers? I'm seeing C and I'm seeing D. But which one is correct? Which one is correct? So we know it's not temperature control. It's evident nobody thinks that it's temperature control because we have to have temperature control. We talked about the whole temperature range and what is optimum. And nutrition for yeast, we said that the yeast needs sugar, basically. So even though we even added fruits, we added excess sugar to ensure the yeast has some sugar to convert to alcohol. But is it C or D? The correct answer is C. So it is oxidation. That is not a requirement for fermentation. Not a requirement. So Stephanie was the first person to get that correct. So she gets that point. So let's move on to another question. All right, so what is the name of the major enzyme involved in fermentation? What? Yeah, actually. That's 2 points, guys. And it was shown when we were looking at fermentation, the chemical equation, the stoichiometric equation, that is. What is the main one? Of course, we have more than one enzyme that works, but so the major enzyme, I'm seeing 2 different ones, which yeast has both of those enzymes, but there's a major one. If you look up fermentation anywhere, you will see yeast invertase. Saccharomyces. I should have asked one of that, you know? Jeez, Michaela. You give him a question. Ricardo. Sure. Um, you give him a question. I should have asked you guys what the name of the yeast is, you know? It spells slightly incorrect, but the name of the yeast, the name of the organism is Saccharomyces cerevisiae, but the enzyme itself, the major enzyme, is yeast invertase. So the first person to get that correct was DeAndre. First person to get that correct was DeAndre. Yeast invertase. Gala, come, please come up on the stream. So we're at question 11 now. Yeah, we're at question 11. That question is, at which two stages can filtration occur? There are two main stages at which you can carry out filtration. What are those? Fermentation and clarification, crushing and bottling, fermentation and aging, crushing and clarification. A, B, C, or D. Hopefully we were paying attention and we know what takes place at each stage. All right, so I'm seeing the answers A for fermentation and clarification. Michael is saying D for crushing and clarification. No, where Ricardo said D, you know. God bless what you asked. Any more answers, guys? Or you need time to think about it? Michaela says D, crushing and clarification. Any other answers apart from A and D? Which two processes involve filtration, or at which we can carry out filtration? No other answers, or A? But that can't work. You have to pick one answer. You are free to change your answer, but the answer that I will use is the final one. So, do you want to change from D to A? That's perfectly fine, but I'm going to use the final answer to determine whether or not to hit the point. Why couldn't it be anything other than A or D? Nobody has a B or C. You don't think you could have filtered when you're doing the bottling? Because you guys don't think you can filter when you're doing the bottling? Or after aging, you filter? No? Well, the correct answer is indeed D. So I think Mikkel was the first person to get that answer correct. Mikkel gets that point. No, which answer color change, because you never have no answer to begin with. So our final question, what happens if a suspension is exposed to air during fermentation? And you must explain this to me, because may I give you a whole of 3 points. You got to explain what happens if the suspension is exposed to air during fermentation. So you can't give me a 3-word answer. You have to explain to me what is going to happen. Oxidation. Wow. Me just say you can't give me a short answer for 3 points and you just say oxidation. Oxidation of ethanol to ethanoic acid. Okay, but how that even happen? You just put on the ethanol, it gets some air and it just turn in a ethanoic acid. Is that the case? Is that the case? Ethanol oxidation. The ethanol becomes acetic acid. Ethanol is turned into ethanoic acid. Everybody has said the same thing. I can't get no more explanation than that. The yeast invertase uses the oxygen to convert the ethanol to acetic acid. Boom! There's the answer. That was a nice answer. Which explosion? Ricardo? Oh boy. So Mikhail gets those points. Mikhail gets the point, guys. That was a nice explanation. So I'm going to, I think Mikhail can go over the points from last week, and then I'm going to tell you guys this week's points, and then we total that. So you can either say it using your mic or post it in the chat. The point standings from last week. So last week we did, well, you should know what we did. What did we do last week? I think most persons that are here now were here last week. All right, so last week, point standings, Jophine was at 30, Stephanie at 60, and Mikhail at 10, Ciandre at 50. So this week, we have Stephanie with 30 points. So that means your total is 90 points. We have Jophine with 70 points. The total is 100. We have Ciandre this week with 40 points. And we have Mikhail this week with 40 points as well. And it is so strange that the same persons who scored last week are the same persons who scored this week. So, total points now. At the top is Jophine, because Jophine determines someone answer first place. So Jophine has 100 points. followed by Stephanie and Ciandre, which both have 90 points, and Mikhail has 50 points. That's Jophine at 100, Stephanie and Ciandre both at 90 points, and Mikhail at 50 points. So those are the scores total for, not for this week, but for last week and this week. And that is the end of today's meeting. I'm going to show you guys the setup that we have right now with the bottles and everything. So we've added the corks and everything to the bottles. So this is our banana, that's the pineapple, and this is the apple banana. We added the yeast and everything. Why does it look like that? Oh, what happened over here? It just looks strange. Is it apple? Or it just a move fast? I don't know. So we've added these cap. This is a dilute solution of ethanol. Yeah. So this, if we have any microbes coming in, it will kill it. These, and it allows the carbon dioxide out of the bottle to go up, and there are these little holes at the top that allow the air to escape. And that's the setup. So we're going to leave these in the lab. Maybe I'll come tomorrow and look at them for you guys and see. Yeah, I have lab tomorrow. So yeah. I'll come tomorrow, check them, take some pictures, see what the progress is. And yeah, that's the end of today. This was a lot of work. Trust me. A long time. Never so much work. They are love. So we'll see you next week, guys. Next week, what is on the agenda is to do some ice cream and yogurt making. Will we do ice cream and yogurt making? Stay tuned to find out. I don't know. Maybe we could do some nitrogen, you know. Anyway, so we would need that for the ice cream making. And then we will also want to do some pectin extraction. So I'll see you guys next week for another experiment. We'll see what's happening next week. I will let you guys know. Bye. Say bye.